Yankin, yes. Can you hear me?
Hello? Yeah, I can.
Yes. All right. Updates, please. Yankin.
So what's the difference? Not much really, actually.
No problem. Since
Not
Thursday,
just
yeah.
changed. And yeah, I mean,
Mhm.
no, actually, no.
Okay.
Since Thursday, there's nothing, I don't think.
Yeah. How's the DRV, discrete random variable, on Friday?
It was fine. I mean, it's just what you said would happen. Though. I mean, let me get it. Give a second.
Right. What exactly happened on Friday? Sorry.
I mean, we just went through the lecture after we reached until
Before the expected value. Before that, or
yeah, before the expected value.
Right.
I think we just discussed the what's it called, the C, and then after that C fraction and power X.
The examples, the work examples.
Yeah.
So at least let me get one thing clear. Us discussing the note, right, before the lecture, right, before you see the video or before you attend the lecture, and we just blaze through, and discuss per points, or do some skip here, skip there. Is that actually useful for you?
I mean, the lecture did fill in some gaps, I guess.
Right. So if we don't do what we did on Thursday, right? If we don't, blazingly discuss everything and leave a lot of question mark, if we don't do that, is it a loss? Is it better not to do that?
I think
is it a waste of minutes to not do that? To do that?
I felt like I went in knowing something. But I didn't feel like it was a waste of time, but I'm kind of neutral about it, like I think it's good that I went in knowing something, so knowing nothing, but I'm not sure like this early into knowing the subject, I'm not sure how learning it beforehand will affect me. So
I'm less ambitious than that. I'm just aiming to, does it impact the lecture time? Does it make the lecture more useful?
I guess it does.
Then I'll go a bit further than that. Something that you can answer soon, maybe not now. Does having better lecture in that way impacts your tutorial, which is you're probably going to do next week, I'm guessing, because you are still at the probability tutorial, right?
I mean, we haven't even started the probability tutorial.
So a bit too advanced, but you'll probably be doing it maybe at most at latest early next week. Early next week probably lah.
Yeah.
1 week from now. So I will keep that question until then. So, starting that lecture well, will it impact your tutorial or will it impact your next lecture on DRV? The one when they finally talk about the expected value lah. Because I think that's where that's where we want to discuss. I feel the rest are just setting things up. So maybe there's a further question than that. Maybe lah. So I guess that's my practical question. Because if it is not useful, then maybe we should use the 45 minutes for something more useful, if it is possible.
Yeah, okay.
Right here, accounting. Right. Okay, so that's for math. Now today for you, Yankin, can we finally talk about physics?
Can we finally talk about it? Why not?
Right. Is there anything else to talk about? That's my feeling, is that there isn't anything else to talk about. Finally.
Not at present. Most of the stuff is out of the way. Right.
So now, when we talk about physics, have you tried the question or you don't even have any question yet?
I don't think I have questions yet.
You haven't tried a lot of questions, or?
No. I'll be honest. I've been focusing on like bringing chem back up to speed. But now physics is still.
So where are you in chem?
Where am I in chem? I am in the couple now, I guess.
Tutorials. Tutorial.
Yeah, I'm here. Yeah, pretty well I hear class.
I like that. Is there any honest question on carbonels, the tutorial?
Not yet. I expect I'll get some, but no, not right now.
All right. So I'm glad that you are able to do the carbonel tutorial with, I suppose, better than expected confidence, I think, right?
Yeah, I'm referring to my school's lecture and like some of the steps that we didn't go through.
Yeah, I like it. So what we did before, like we spent time in carbonyl and hydroxy, right? In pretty much the same manner, right? I just blast through and then you kind of try to do tutorial and it does seem to have some good effect, right? Right, good. So can we now at this point, you just try your physics? Just try to do the question, right? And then we'll see where it goes. We'll see where it goes. Okay. Right. Okay. So Austin, give me some updates. What's happening?
New lectures.
On physics and math, what are they?
14B math, and then
Finally, right?
for physics is what is it called? Electromagnetism.
So
And
electric field is done. Electric field is done.
But the tutorial's not done.
Ah,
It's
right.
just new, like.
Okay, right. Understand. And then, sorry.
Yeah, and then for chem, I think it's carbon. No. Carboxylic acid.
Right. I'll leave chem to the other tutorial, right?
Yeah.
Okay. Now, regarding physics, usually people have questions on the tutorial of the electric field. Usually. And if there is, be happy. That's like a great thing to do. For APGP, if you're ready to discuss the money one, 14B1, also a good thing. Also a good thing. But if you want to discuss something before that,
the 14B, right? That's one, right?
Okay. Then Yankin, I'll answer Austin's question first, right? Okay,
Yeah.
so Austin, Jamboard, yeah? Jamboard. New Jamboard for today.
Wait, I think it's lagging.
Yeah, sure. Oh, what? 14B, you start with sigma notation? What? I don't, what? Huh? What?
My school is very weird.
We have been using sigma notation, right? We have, right? Right, okay.
I'm not sure, but this was the lecture we're supposed to watch by Monday.
14B is not money. Yeah, 14B is
there's no money.
So 14C is money. Oh, wow. Okay. Yeah, I don't mind. 14B is important. It is important. So I don't mind. Definitely, if you have an honest question, I want to help. If you want me to help you go through the lecture note, I also don't mind. Right? So your choice.
I honestly don't understand it. I don't really understand.
Sure. Ask me questions immediately, like starting from this first page, because you've gone through some, right? Anything that you want to ask, you ask immediately, right? Where's your Jamboard?
Oh yeah, right.
Right. Same thing, Yankin. Where's your Jamboard?
Yeah, I sent it.
All right, got it. Yeah. Okay, got it.
I share it.
Right. Okay. All right. So, what confuses you, Austin? Yeah, this one's fine. The Zoom is fine. So, what confuses you in the first or second or whatever page?
I'm confused about this one.
This rule 3, yeah. Okay.
Yeah.
Let's talk about rule 3. Let me just take a picture. Okay. So I think my goal for you is to make you comfortable with the sigma notation. If psychologically, if you're not comfortable, I think that affects how you approach the question later on. So A to B, right? A to B. Now A is something bigger than 1, correct? A is something bigger than 1. Right? So what he's saying is something like this. Yeah. Yeah.
Sorry.
We are lagging. We're lagging badly. Sorry. We're lagging badly.
Can rejoin. Yeah, I'll change my internet.
Yes, please. Yes, please. I'll wait.
I think my internet is...
Yeah, it feels bad. It feels bad. It feels bad. Okay. I'll wait for you. Right. Okay. So Yankin, maybe we start with your question if there is a question. Okay, this one you have to zoom in. I need you to zoom in. Okay, zoom out a bit. This is too big. Thank you. Right. So your question, is it question 10?
Yeah, 10 part 2.
Okay, 10 part or the wavefront, blah blah blah. Right. Okay, great. Right. Wave for maximum amplitude. That would be right.
I'm not really sure what they're asking for.
Okay, okay. Number of directions with okay, right. So I'm gonna take a picture of that. So traditionally, wavefronts are crest, not the throw. Am I making any sense? Traditionally, lah.
No.
Okay, right. So obviously, with crest and crest intersecting, that's really that is a maximum with maximum lah. But of course, with throw and throw, you also have a maximum throw lah. You also call that constructive lah, right? Okay. Now, maximum amplitude can therefore mean maximum crest or maximum throw. It means both lah. Okay.
All right.
Draw. All right. So let's investigate AB first. So here is your maximum crest, and here's your maximum throw. Then maximum crest, maximum throw, maximum crest, maximum throw. Okay, make sense?
All right.
Okay, now he wants a number of direction between ABCD. So he's basically saying a line. So how many lines? How many lines in between that will have this same characteristic? So maximum crest, maximum throw, maximum crest, maximum throw. Okay, so let me.
This is very. So
are you
here?
Okay, let's investigate because there's a point, right? Now, clearly that point is maximum crest. Clearly, right? And then if we go along a line, you have to decide the line, I suppose. Which line are you talking about? It's best to use pencil. It will be nice to use pencil, right?
Yeah. You get a ruler.
That would be nice. Yeah. So Austin, are you back with a better connection?
Yeah, is it better now?
It looks much better. So I'm going to answer Yankin's very quickly. Yeah, you do something else first, right? Okay.
Okay.
You are doing okay. You're having a lot of maximum crest, so I think that's a good idea, right? So you go and line that. Yeah, just whack the maximum crest. So yeah, not a very nice line, but yeah. So as you can tell, now you realize it's not a perfect line. So now you realize, because now that we think of it, A and B is not actually a line. It's more like a slightly curving thing, right? So now we learn something. So I'm gonna follow yours first. Okay. So like that. So that's what you intentionally want to do, right? So you have maximum crest here, and then obviously this is also maximum throw, right? Maximum crest, maximum throw, maximum. Now the question is between this, I'll call this E and F, whatever. Now between E and F, do you between EF and AB, do you have another maximum crest, maximum throw?
I think so.
All right, try again. Right. Okay,
here?
go. Yeah, don't use a ruler now. Okay, now, okay, great. Now between that new line, let's call that new line, I don't know, whatever, like X and Y, right? Between X and Y and A and B, is there another maximum crest and maximum throw?
No.
All right, so you count all the lines like X, Y, E, F until from AB to CD. If that makes sense, right? Now the second challenge will be the minimum lah. So minimum amplitude means you have to meet crest and throw. You have to meet crest and throw. You have to investigate where crest and throw, and that's slightly harder to see, and this is therefore a good practice. I'll leave it to you. Okay. Now back to you, Austin. Yeah? So Austin, let's say I agree with you that this is A. Yeah? I agree with you. I'm gonna scratch this for a while. So all this thing is smaller than A, right? That's it, right?
Yeah.
And actually, this is not B. It doesn't make sense. This is B. Okay, don't call this B. It doesn't make sense to call that B.
That's just my lecturer.
Okay, I'm gonna do something slightly different. If you follow and you don't understand, then there's no point. So B, we just say that B is bigger than A, right? That's I think that's what makes sense, because we say from A to B. Okay, so A is smaller than B. Okay, so far so good, right? Right. Yeah. So this, I'm going to use a different color. This is sigma from A to B, right? That's it lah. That is it lah. correct?
Yeah.
And now using a different color, this is sigma from 1 to b. I think that makes a lot of sense, right?
Oh, yeah, I copy that.
Okay. If that makes sense, those two things, the green and the blue one. Does that make sense, Austin?
Yeah.
Right. So the a minus 1, I'm going to cancel. I'm going to put a minus 1 here. This is a minus 1. The guy before a lah. Then a minus 1. Okay. That's it. Okay. So this is sigma from 1 to a minus 1. Right. The blue, the green, the red all make sense.
Wait, yeah. Wait, A minus 1 is in the middle of 5 and A.
No, not in the middle. It's before a. You only give me such a little space, but what I meant is before a is a minus 1. Simple, ma? For example, a is 10, just for example. So a minus 1 is 9, for example. In fact, I'm going to do that, okay? I'm going to say that a is 10. So this guy is 9, no? This guy is 9. Can? 9,
Yeah.
So 1 to 9, and this is now 10, no? Like something like that. As in, I'm sorry, I'll put it 10 minus 1, which is 9. So the rule is not a rule. I don't even know why the rule is mentioned in the rule. The rule makes full sense. 10 to b is equal to from 1 to b, the whole thing, minus from 1 to 9. I think that just makes sense. It's not even a rule. I don't know why it must be a rule. It's something that makes sense. What? Does that make sense?
I guess.
Yeah. And have confidence in that. There is nothing else to this rule. The rule simply says something like that. I want from 11 to 20. Okay, I'll have from 1 to 20, and then I'll minus it from 1 to 10. Why from 1? Because from 1 is always easier to find. From not 1 is not very easy. So he's saying that, I know you want this, but this is more direct, and this is also more direct. Trust me. That's what he's saying. That's what he's saying. So let's see whether he's correct. I believe that's the practical consideration. Okay.
I see.
Right. Let me help Yankin a bit first. So Yankin, are you finding the minimum guide?
I feel like these lines are confusing me.
Okay, I'm gonna draw the two lines here, right? And then I'll go back to Austin. So now let's concentrate on the crest meeting the trough. I'll give you an example. There, that's the crest meeting the trough. That's a green. Don't you think that's crest meeting trough?
Really?
Because you cannot see the trough. The trough is between two crests.
Yeah.
You cannot see the trough. The trough must be imagined. You know, if you draw the trough, it becomes very confusing. You know, there's a compromise here lah. You draw the trough, okay, but it will become more confusing. So this guy is also definitely crest mid trough, definitely. Correct. Also crest mid trough, also crest mid trough. You know, and this is not a coincidence that this is in the middle of these two lines. It's not a coincidence. In the middle of the maximums, you will get the minimum.
Yeah, the minimum. So it's like the right thing.
And you just check the other between the other two lines. You will find the same situation, right? So imagine the trough. Okay, I'll leave it to you for now.
Wait,
yes,
then why is it just say one line? Okay, I just.
Yeah, you can just draw one. If you draw so many lines, then you know, very confusing. You know, right? There are more than one line. There are more than. So Austin, next question, please.
Next question.
Just clarify your note. It's fine.
I'm not sure. I only stop until here. My teacher told us to watch until page 5.
All right. Are you sure? Nothing to clarify? Then we can do a bit of, we can do some things. We can do some things together.
I can try tutorial.
No. We should do the note a bit first. No. We should. Oh. You're not ready. You're not ready for trust me. You're not ready for a tutorial, right? So
okay.
Let's say this one, right? Let's try example 20. Let's try. You try first, and then I think you will be needing the guy below. Yeah, you'll be needing the guy below. The guy below is the standard expansion, right? You'll be needing it. Right? So just saying. Okay. Now, give it a try, but don't wait too long before asking a question. Okay, so Yankin, are we done with that question?
No, I tried to. I don't know if you can see it.
Right.
I
I mean, I can see your
think
line. A line seems like that's definitely like crest throw. That's crest meeting throw. Yeah, I think so.
I think it gets a bit more muddled at the bottom when like the line curves.
Correct. And when the space gets smaller, but you get the point. Okay, you get the point, right? So again, the throw is there for you to imagine.
Sorry, I have this question.
Zoom out, please. Zoom out. Please. All right, and show me the complete question.
Number 2.
Zoom out a bit more. Sorry, zoom out a bit more. And
sorry,
please.
This is the like.
Okay, let me just at least copy that. Okay, this is a very standard double slit setup. Yeah, very standard. Okay, so I'm going to put it in the Jamboard. Okay, feel free to ask the question. Show me question number 2.
My question is, I'm pretty sure it's theory, which is why I'm stumbling. But it's this one. Part 2.
Why in practice interference fringes? So the fringes that he refers to is the ones here, the bright dark thing. So B dark thing. Okay, then if light for a single slit in split into which is basically like this. So here's your one slit, right? Your one slit.
Yeah.
And the one slit will travel here, and then automatically you have your double slit, right? Now, because they already tell you the reason from part 1. So part 1 is for some reason I needed to be coherent, right? Now, what do you understand about coherence?
It's when the two waves are of a constant phase difference, right, from each other.
Correct. Right. So you're correct. So now, why in practice?
My teacher added the condition for A level that for coherence, they will either be in phase or anti-phase. They will never test like in between.
Correct.
Like in phase or anti-phase.
Which is very unnecessarily complicated, right? So what your teacher is saying is either like that and like that, or like that and like that, basically. Okay. So in practice, right? So considering all the practical situation, so it's not in theory. No, the question even say in practice, you can only get a coherent beam if you split from one source. That's all. Of course, this is 3 marks. That's the most basic question. It's very difficult to get something like this or something like that without starting from 1. And that one must still, for double slit, it must still be monochromatic also. So splitting from 1 to 2 is the easiest way in practice to get coherent double slit. Okay. Now I'll leave for the tutorial to answer more detail, like why is this 3 mark? You see all the details. This is a good learning for how to set up a double slit. Okay.
All right.
Right. So then part 2 is basically saying, if I don't consider the practical stuff, how can I don't start from a single slit? The question.
I mean, use laser.
The monochromatic light source is already a laser. There is no such other thing. There is no other thing which is a monochromatic laser source. Right. Now, I'm not gonna concern yourself too much in part 2. Even if you don't know, you're gonna know in the tutorial. That's
all right. Fair enough.
Part 2 is probably less practical. Now, however, part 3, part 4, part 5 will be nice. Okay, will be nice to understand. Right?
Yeah, I think I can do those.
Yeah. Okay. So Austin, what is your question here? Are you stuck currently?
I don't want to put it here.
Okay. So what you're starting, I like that you're separating. So because you can, okay, you can. I'm going to copy that. Now, do you actually, now that I've Okay, I'm not sure why you're confused. So it's good to, I think I want to know why you're, I think I want to know. So what you're writing is great. Now, this one is clearly this one, done, yeah? That's the done deal. Right?
Yeah.
And is this one? So let's start with the easy one first. Is that that?
Wait, what? Wait. Let me get Jamboard.
Mhm.
Yeah, which one?
So this one, the new Jamboard. So is this, or optionally, is this that? Either one, either one. Is that settled first? That's the easier one. Ooh, you don't answer directly. Yeah? Okay, go down to the later part of the page. So here they give you, just consider it a cheat sheet. This is gonna be given in F26. The summation of series involving standard series. Go down. Show me the that one. Look at the first guy.
Yeah.
The first guy, I'm gonna copy the first guy. This guy. Look at the first guy. In the Jamboard, do you think about this first? It's not showing up. Do you think about, my goodness, it's so small. Do you think about this first guy when, when going from here to here or here to here, whichever.
Yeah.
Again, going from here to here. Do you think about this guy?
Let me see.
Yeah. That means you should be able to go from here to here. No? In fact, in questions, they don't do this. In fact, in your tutorial, they try not to do this. They just try to jump from here to here. So it's good to get used to jumping from here to here. That's the easy part. Is that clear first?
Yeah.
Right. If that's okay, then let me answer the second part.
Wait, Clark.
Yes, please.
Why is it n minus 2, n plus 3?
That's what I'm asking. That is what I'm asking.
Oh.
So I've seen a more complete description of this. Remember, this is a formula given. So it's as if you. Never mind. Look. I'm just going to explain it first in terms of AP, okay? I'm just going to explain in terms of AP. Okay, Ken? AP. This is an AP formula. Give me the AP formula. Write down the AP formula. In here, write down the AP formula here. The AP formula for the SN. This is SN AP. Yeah, that's nice. Yeah, that's nice. Yep, and over 2, come on. The first guy, right? And over 2, the first guy, which is A, right? Plus n minus 1, the common difference, right?
Yeah.
Okay, good. Now, let us compare this guy. Let us compare this guy with this guy. Let us compare this guy with this guy. But look at this. Look at this. In this case, what is the first guy? The first guy is 1. And then the common difference is? The common difference is?
1.
1, yes. And the final guy is n. So try applying this here and then see what happens. Try. Let's see what happens.
Apply.
Yeah, apply like, oh, now I know that this guy is 1, right? I also know that the common difference is 1. So try doing that and see what happens.
Become n.
Sorry.
It'll be.
No, just try. It's not n. Just try.
Yeah.
Yankin, you okay so far?
Yeah, I'm just filling in some of the details.
Sure.
From part 4.
Sure.
I hope I get it. 4.3 millimeters. Slit to Q. It needs to travel.
Wait a minute, there's some.
Split this up into 2.
Wait a minute. Wait a. Let me try. Wait a. Sorry, Austin. Let me try.
Yeah.
What's going on here? Oh wow, it is. What's going on here? Wait a minute. I know why it's like that, but is there something? Oh my goodness. I'm sorry, yeah. I think I've written the formula wrongly. My apologies. Please check. There is a 2 here. Please check.
Oh,
Please check the APGP, the 14A. Please check. I believe there's a 2 there.
the actual formula.
Yeah, like the SNAP in the 14A. No, I think there's a 2A there.
Let me check.
Right.
So that's from origin. Origin is 4.3. This one is 0.19 above the origin. So that's 4.3 minus 0.19.
Oh yeah, it's a 2.
Right. So try see whether that fits to this thing. So adjust a bit. Right.
Well, then it should fit, yeah.
Yeah, so it should be, yeah. So then you have n over 2, but here you have n plus 1, right? Now, you can use the formula to understand, or I'll give you something which is a logic shortcut. So it's a logic. So look. If I want to sum this up, it's there's n things here, right? There's n things here, correct? The n things here.
Yeah.
So for example, if I want to sum from 1 to until 10, I can actually do this. I can actually do this 1 plus 10. And then I take average. So that's what I mean. So 1 plus 10, this n and this n, and then I average it plus 2. Okay? And over 2. And then I times how many things are here. So how many things exist between 1 and 10?
And A or 10.
10, correct. 10. Now this always works, This shortcut logic does not depend on this formula. The logic is I take both ends, average them, and then I times how many things from that to that. It always
To
works.
sum it up, is it?
To find the full summation without referring to the formula.
As in how many terms there are, or like the
how many terms? So I'll give you an example.
Oh,
so
okay,
1 to 10.
then I really
10.
learned how to find out the number of terms.
But from 1 to 10 is quite easy, right? From 1 to 10.
As in this one.
I think that, yeah, but what are you saying that you want to rely on this formula? B minus A plus 1. Are you sure?
It's just the last term minus the first term, then plus 1.
Correct. So give you an example. Because if you rely on this too much, I think you will forget in exam. That's my worry. So you watch this. So let's say now my series starts from 13. Okay, a very weird number, and then plus 14. Easy, right? Plus dot until I don't know 203. No, not 203. So I'll make it even more confusing. 207. How many terms exist between 13 and 207? Would you like to rely to the formula, or would you like to use a logic, or would you use something else? That's how many terms?
If it just if I use the method like
the formula method, right? So 207, right? 207 minus 13 plus 1, right? Minus 13 plus 1. Okay. Me, I'll use a slightly, I feel a better logic, because it relies on some logic rather than formula. Oh, there are 207 things from 1. I know 1 is not included, right? So 207 things minus 12. Minus 12. Please try. 207 minus 12. Oh, just use a calculator. Sorry, just use a calculator. 207 minus 12. is, of course, equals to 19 because 207 minus 12 is 207 minus 13 plus 1. I find minus 12 to be slightly better in logic. So whether you use this logic or whether you use your formula or something else, finding the term is not a very difficult thing to do. I hope that makes some sense.
Oh, yeah.
Right? Okay, now I'm going to use that. So now back to 13. So from 13 to 207, you have 195 terms. So how to find the summation of all this? You can use the formula or you can use something like this. Sn equals to 13 plus 207 over 2. The average, right?
Yeah.
The average times 195. Okay. This will explain this, but why am I discussing this? Because it will explain this thing. But first thing first, this is what I'm going to do. And now use the formula to confirm my working. Now use the formula. Use the formula. See whether this logic is correct.
Oh, which formula?
This thing lah. There's only one Sn formula. This thing lah.
Oh.
Right. This thing.
1, 2, 3, 4, 5, 6, 7.
So yeah, 195. Yeah, over 2 plus 2 times what? Yeah, 13. I agree. Then plus right 194 lah, right? Okay. Times the d is 1, right? In this case, it's very easy lah. The d is 1. Kindly check again. Oh. Is the bracket correct? There should be a double bracket, I believe, at the behind. I feel.
Yeah,
okay. Okay. Then please check whether this is the same as my shortcut. My shortcut is as simple as first guy plus last guy average, then times 195. Please check. Yankin, your
Yeah.
Alright.
54.
Is it the same? All right, good. Now you understand my logic, yeah? My logic is I hope there's some meaning to it compared to following the formula. Both will be correct, right? Now to explain this thing, this thing is, if you notice, right? The last guy, right? Plus the first guy divided by 2. Okay. Okay.
Oh.
The last guy plus the first guy, average lah, average. Same thing with this one.
Yeah.
Exact same thing. And then times how many terms, right? Times how many terms? How many terms exist between 3 to n? How many terms?
N minus 2.
Yep. Voila, there you go.
Oh.
I think that's how you make sense. If not, then you have to memorize, then memorizing is bad if you don't remember it. Okay. Would you like to write things down here, please?
No.
Okay. Then we'll explain the front one. The front one is not that difficult.
Oh, I have a question actually.
Yes, Yankin. What are we referring to?
Okay, so let me get it on the screen.
There's this.
Part
Wait.
5.
Wait, how come I have the? Wait, where did the? How come I don't have the? Sorry, how come I don't have your? Okay, never mind.
Oh,
I still remember. No, I still remember. Yeah. It seems to be gone. No, never mind. Your question is what?
Part 5.
Describe and explain the event once it is covered with a thin sheet of transparent. Okay, so this is a fancy way of saying. Oh wait. Before you do that, do you know what happened? My goodness. So sorry. So my guess is this is his fancy way of saying. Instead of that, now it's like that lah. That's his fancy way of saying things. Right. So it depends on how you understand the physics of transparent material of high refractive index. So it goes like this, bang, bang, right? Something like that. Here's your thin material. So you get dun, dun, dun. What happens when a material goes through this and goes through that? Do you know what or not? Does your note explain this?
Refractive index, isn't that light from O level?
Like for example, this is air, but this is for example glass lah. Let's just say that glass has a reasonably high refractive index. Okay. Do you know what happens when this goes through glass?
It
Any
either
idea?
bends.
No.
Is
This
it
one is
bend away?
well, fair enough. It does bend. So because now you're hitting the slit like this, like this, like that. Now the original path will be like that, and then this one will probably be, let's see, so you bend like that, something like that, something like that. So it'll drop slightly, so to speak. But I don't think that's what they are focusing on. I don't think so, because he say thin. Thin means this difference will not be much. Let me think for a while. The wavelength is very small. No, don't answer this question first. Let me just think what they're trying to aim here, because it's very vague. He doesn't explain how thin the sheet is. He also never addressed one other thing that I think is a problem. So never mind. Okay, skip 5 first. I'm going to come back to it. Okay, Ken?
All right.
Okay, you go to the next one. Now, Austin, are you ready for the front part?
Yeah.
Now, this is last day I meet you. Right? So, Austin, this to this.
It's Wednesday.
Oh, sorry, Wednesday, what I'm talking about. So last week I'm meeting you. So this to this is a very common thing to happen even in exam. They just expect you to be able to do jump like that. So it's good for you to, okay? Right.
Yeah.
Now, the front part actually also, I think it is to their expectation. So now let's watch this guy. So we're gonna ignore the tree. This is going to be ignored. Just gonna watch this. If this is either AP or GP, then they expect you to know. They won't warn you. Is this either AP or GP?
Yeah.
What is it? What is it?
GP.
If this is GP, and I think you're correct, then they expect you to be able to identify the first guy, to identify the R, and to apply the SN of the GP, and voila, done. This is the result of the SN of GP. So now, in the middle here, apply SN GP using the formula that you know. And you will probably get there.
Wait, the one behind is AP, right?
That's SNAP, which you did lah. You did already lah.
So it's AP.
Yeah. Please write down it as SN to differentiate from UN. Do you know what's SN? Sorry, summation lah. Summation.
Yeah.
Right. So just want to emphasize that this is not UNAP, but this is SNAP lah.
Also, this is SN of GP and AP, right?
Yeah, both and SNGP, SNAP, and then you just treat them separately. Okay, Yankee, any questions so far?
Well, not really.
All right, sure.
They're not giving me numerical values here, so I'm not sure.
Zoom in a bit. Just zoom in a bit. Zoom in a bit. And then, is this the start of the question? Sorry, is this the start of the question? Or is there something else?
Oh, that's all this one.
Oh, can you zoom up? Sorry, a bit too much. Okay, I'm gonna copy this one first. Don't delete it. Okay.
Not really the biggest question.
Okay, I go toilet.
Yes, please. Right. So ask me this page first. Is there any question on this page?
This page?
Yeah. Is there anything?
Not yet.
Okay. Sure. And then let's go to the next page.
Yeah.
Right.
My issue is that they're not really giving me values for like a period here. They just like separate.
So basically, they just give you. Let's just consider this an oscilloscope, right? This microwave detector is probably an oscilloscope, and the oscilloscope axis, the scale, is not given in any way for the y-axis. For the x-axis, I think it's given, right?
Because they're asking me to find the period, right?
The period is x-axis, one.
Yeah, I know, for the waves. So it just the period is like that, and just So it's like
Oh, look.
some
Okay.
arbitrary-
So look, practically this happened, right? To be fair, they're giving you a practical problem, right? This is not a theoretical problem. Practically, they don't just line up with this. Well, here's the clue. This guy lines up. This guy lines up.
Which guy?
That guy lines
Sorry.
up.
I'm on the wrong
Jamboard,
page.
please. Yeah, Jamboard,
Yep.
please. Jamboard. Yeah. This guy lines up.
Okay.
Don't choose this guy. Practically, this guy exists, but this guy lines up. Choose the best place lah. Choose the best place to
No, just
measure
after
lah.
that, I'll just divide by the
Three.
number of
Yeah.
waves.
Which is in this case how many?
1, 2, 3.
Yeah,
Three,
so that's nice. Yeah, so the second guy is harder. Which point will you choose? The second guy is probably harder. Where will you choose your point to
I thought it
divide?
was. Oh, I guess.
The smaller guy, yes, smaller guy. Not
Isn't
easy,
this-
not easy.
No, it's not. It's not 1. Oh my god, it's like.
Look, yeah, this is not easy. This is not
away.
easy. This is not easy. This is not easy. Not easy. Not easy. Not easy. This is not just exactly there. No, not easy. Not easy. Find a point which is easy. Do you find?
Here.
That point is also easy.
But
Divided by how much?
But it's not like a complete wavelength, so it's like.
Yeah. Divided by how many?
2,
yeah. How do you count your one? Sorry, how do you count your one? Sorry, let me show you your. Show me your one.
So it's from.
Where's one? Where's one?
Here to here.
One. That's
one.
Nice. And then. And 2. Where's 2?
Here to here 2.
Right, and then.
What?
Hey, turns out it's also 3.
Oh.
See, don't let it fool yourself lah. Don't let it fool yourself. Okay, so you do that. So Austin, have you? Oh yeah, you got it. You are almost. No, you're almost there. You are. I mean, almost. Wait. Let me see.
But this doesn't look like.
The A. Wait. Sorry. Sorry. What's the A? 8. Oh no, the A is 8. I'm sorry. Then the ratio is R2. Yeah, I like that a lot. And then I disagree that the N is N. I totally disagree that the N is N. Totally disagree with that. Totally disagree with that.
What?
N is how many terms, right? How many terms from the first guy to the last guy, right? So how many guys from the first term to the last term?
N minus 3 plus 1. Oh, yeah.
Hey, not N minus 3. Hey, not N minus 3.
No, plus 1. So it's N minus 2. Yes,
N minus 2. Yep. In action, right? In action. Good. Now try to adjust this to, I mean, you'll get there. This now just mathematics. Please adjust properly.
I get negative 24.
Phase difference between the waves, that would be, oh boy.
Oh wait, did he swap it?
Sorry, you're saying?
He swapped it around. So it's
yeah, so the minus go in. The minus go. Yeah. And then you are done because you have the 3 outside. Don't forget there's a 3 outside. Okay, right.
This, right?
Yep, and then there's a 3. So in this example, it's more like recognizing the IP and GP and then using the what you're in. It feels more like that, I feel.
So I write inside here.
Yes, feel free to do so. I feel what you wrote in the left is much better, but of course, whatever you want to write here. Your left working is great. Okay, I like it. Any questions? Yeah. I mean, doesn't matter. What matters is that you know what's good.
Okay, then what do I write here?
I don't think it matters. Like, for example, I told you in exam, they accept going from here to here directly. They accept. I don't think it matters. But if you want to write this, that's fine. As long as you understand what you mean. Okay.
Huh?
I value any food, yeah. I value any food, yeah.
Yan Kian, you okay so far?
I think so.
All right, sure.
Let me just
Sure.
make sure I.
Austin, are we ready for the next part? Yeah. Austin, are we ready for the next part?
I'm ordering for my mother for
Sure. Call me
two,
when
two
you're back.
minutes. 2 minutes.
Yeah, yeah, okay. Call me when you're back. Okay, so
Hmm. I Sorry.
yes.
The phase difference. I thought. Maybe it's a misconception on my part, but if the waves are of the same period.
Yeah, they don't know. That's not what phase mean lah. No. Yeah. So it's very easy to see visually. Okay. Like I said, it's very easy to see visually. Look. If I'll call this guy, I'm sorry, I'll call this guy the curve A. So I'll write it in black, red, and then this guy will be blue lah. Let's call this. Now, if A and B is like that, and like that, they are clearly in phase, keeping it simple. These are clearly in phase. Let me describe it, try to describe it to you. When he go up, he go up. When he go down, he go down. When he's zero, he is zero. When he's zero, he's zero. When he goes down, he goes down. When he goes up, and so on and so on. This is clearly in phase. Okay? Can?
Okay.
Can. This guy is not. So how do I know they have phase? Well, because they are not in phase. The fact that they are not in phase is very easy to see. Finding the phase difference requires a simple technique. So can we agree first that they are clearly not in phase lah? Because they are just not acting the same way. Okay, that's just how you see phase difference. Are you okay? This is going down and this is going. I mean, this thing is not this thing lah. It's not.
Yeah.
This thing is from the peak going down. Agree. This thing is from the zero or the middle guy going down.
See.
And here is going up and this going down. It's just clearly not.
My concern is that this isn't the peak because like
this is the peak, man. This is the peak.
Because I might
see everything.
Yeah, okay.
Right? Okay.
Okay. Yeah.
Clear, yeah? Clear. You don't just see this lah. Obviously, if you just see this, your concerns are well founded, but you have 3 waveforms. It's okay. So can we agree just visually that A and B is clearly not in phase? Okay, now the technique to find their phase difference, no? Because their phase difference is usually the most important thing in any double slit question. Phase difference is the thing. So very simple. My technique is I will identify where the point in A will be like in the same way as the point in B. So this is where they are of the same way lah. What do I mean by that? When they are acting the same way. See, B from here, I'll call this B prime. Okay, I'll call this B prime. B prime is acting the same way as A, acting the same way. When A starts like that and then go like that, B is starting like that and going like that. See, this is where B prime, this is where B prime starts to act the same way as this point. Agree? Okay. So I will say something that is informally correct. This point at A is in phase with this point at B. That's only informally correct, but I hope that makes sense. This point and this point are in phase. These 2 points. Okay? Okay, now to answer the phase difference. So, okay, we do have a phase difference. The phase difference is, I'll use the case of B. How many lambda of B is this? How many lambda of
B. So that's one half.
Not half,
Three
not half.
quarter.
Very good.
Of B.
Correct.
3/4.
3/4 of B. And I think you're quite right in that. So this is 3/4 lambda, and which, if you want to say it formally, this translates to how many radian? 3/2 radian. 3/2 radian. Right?
Times
So
pi.
times 2 pi. Yeah. So the phase difference between A and B is 3/2 lambda. Okay.
Oh.
B is lagging. To be very precise, B is lagging 3/2 lambda compared to A, something like that. That's the most appropriate answer.
Isn't A lagging?
Because you can also say A is lagging, so that's the problem. So the problem is you can also say A is lagging if you continue B like that. Now, if you continue B like that, let's call this B prime. Then obviously, B prime and A is also in the same phase, right? See, B prime and B double prime and B prime is the same phase. So obviously, B double prime, B prime, and A is the same phase. Right? So
okay.
you can also say that this is 1/4 lambda, which is half pi. So which one's my answer? Is A lagging to B or is B lagging to A? Okay, so the simple answer is we're going to ignore this because it starts before 0. So we're going to pretend that this doesn't exist. So just for ease, so we'll just compare this guy, not this guy. Okay.
Okay.
Right. So something like that. Remember the technique? I am identifying the points of the same phase. That's my technique. Okay, Austin, what is your next question?
Yeah, just move on to physics because math, they never asked me to start the tutorial yet. So
yeah, so do your tutorial on this one and pay attention to the money one after this.
Yeah.
Okay, physics. What is your question?
I don't understand how to answer 5.
Okay, wait. Let me name your. Sorry. Yeah. Okay. Right. So your question is question 5. There is no drawing. Okay, so I'm gonna take a picture of that. Okay, so I'm gonna draw. So there are 2-point charges lah. He never explained positive or negative, right? So I don't know, positive, negative, question mark, and positive, negative, question mark, right? For the electric field to be 0 at a point where oh my goodness, right? Okay, so electric potential, electric fields. Are you clear with both? If you're not clear with anyone, please tell me.
Electric field strength is the between two charges, right? The electric field between two.
Yeah, the potential also between two charges. Same thing.
Oh, wait, there was a difference.
There is a difference. If you study this chapter and you do not know the difference between electric field strength and electric potential, big trouble. I
kind of forgot.
No, you cannot forget. It's in every question. You cannot. You cannot forget this. You cannot. It's you can't. Oh dear.
Here. This one.
Oh dear. Yeah, I mean this does not explain. Yeah, these are just formulas and definitions. They are nice. Never mind. First thing first, what I can do is I can use the formula. So, yeah, this is much better. This relationship is much better. This thing is much better. So I'm going to write this thing. I'm going to write E equals to minus dV over dr. So let's focus on this relationship. Now, between the big E and the big V, who is the field strength and who is the potential in the Jamboard? Yeah. Who is the field strength?
The potential is the negative dV over dr.
No. V is the potential. This is the potential. The V.
Oh, yeah.
Okay, the V. And then the big E is the field strength.
E.
Am I correct? Okay, that's a field strength. So
Yeah.
in this case, all electric. So this relationship is telling you something important. The rate of change of the with respect to distance, right? Rate of change of potential with respect to distance with a minus sign, don't know where that comes from, will be equal to the field strength. Don't know why this is so, but this is so for now. It is so. Again, the rate of change of the potential with this will be that, right?
Yeah.
Also, let's write down the proper formula for V and R. Do you know what's the proper formula for V and R? For V and E, I'm sorry. Yeah, that's fair. Yeah. Also, write down the popular formula for V and B. And then we'll do this question. Yankin, any problems?
No, I'm just trying to recall some of the.
Sure thing. Back to that table. The table that you show is at least useful for formula summary. Very useful.
I'm trying to memorize.
Yeah, how many? Yep. Memorizing is fine.
Wait.
But,
wait, E. Oh, wait.
So how many Q for E? Only one. That's nice. Good. Only one. Good. Your E formula is wrong. Your E formula is wrong. You're missing something. Very good. Good.
V
is 1Q.
W over Q, right?
No, I don't want the W of you. I don't want the W. Let's not involve W here. Let's not involve W here. I just want the most basic formula. Don't involve the W here. Maybe in another question.
Negative.
How many Q and how many R lah? Is it? How many Q on top? How many R in the bottom?
2Q, right?
No, 1Q. Check your table one more time. You can check your table one. It's okay. You will be needing
Q
that table.
For, is it this one?
Where's that thing which exists in the table, the nice table that you showed me just now, right? So 1Q up here and 1R up here, and then whatever constant is there, right? And the minus and whatever. Okay.
There's no minus here for this one.
Again, I think the minus is confusing, so I usually leave it out for a while. I usually leave it out for now. Okay. Right. Okay. Now, give me a charge here. Give me a charge for A and give me a charge for B. Anything is fine.
3.8 times 10 to the power of -9.
You want such a fancy number? Okay, sure.
2.
2. Okay. Unit, please. Unit.
+2.
Oh, +2. That's no plus, but the unit of charge is
NC inverse.
Okay, NC. So 10 minus. That's very nice. Now another.
Inverse.
What do you mean by inverse?
NC to the power of -1.
Since when is the unit of a charge Coulomb inverse? I don't get it. The unit of a charge is what?
Oh yeah.
It's Coulomb.
Wait.
It's Coulomb, right? It's Coulomb.
Oh yeah.
Right.
Wait.
Right. Coulomb.
Then the N.
The N is the nano Coulomb. So 10 to the -9. It's a very small charge. That's why it's a very small charge. Right. So nano Coulomb is a common charge. There's no problem there. Give me a charge for B.
-4. NC.
Sure. That's very nice. Now I already put the case already, and I put the formula. These are the three things that we need. And finally, I'm going to put the visualization, right? So the visualization for A is to be like this. So what can I draw? I can first draw E. Drawing E is comparatively easy. I start with 8. And then my arrow is what? How does my arrow work for plus?
Wait. Inwards.
Good, very good. Again, this memorization, so I won't blame you. Right? So no problem. Now for B, I must draw. I use different color. How different must be with A? Right? How different?
There must be more lines, right?
And since this is exactly nice 2, you give me times 2, so I give you 2 more lines. That's just how it is. Simple.
Yeah.
And then the arrow
outwards
will be outward. I just draw 2 outwards. Now I have to connect these 2 lines. I have to connect these 2 lines. So I suppose I'll just use the green one. Yeah. So since this is going out and this is going in, this is probably the easiest to connect with that.
Yeah.
Okay. Now, and then I will be needing to connect a lot of this to something like that. I won't draw a lot, but this is enough. So he wants a point for to 0 at the point where, oh, okay, the visualization is not very useful. It's not,
Yeah.
it's not. Right. Okay.
Wait,
So
but
I'll go back.
since E is equal to negative dv over dr, if
Yep.
v is not 0, means cannot, right?
No, I'll give you the formula. I'll give you the formula. So I'm talking about any distance between A and B. He basically, between. He makes it very nice. So only this, right? Okay. So watch out. The E total and the V total. So I think this is the concept. The E total anywhere here will depend on what? Will depend on E in this case, Q of A, right? I'll call this K, okay? Can I just write this as K? Is easier that way. Like this,
Yeah.
1/4 E naught pi naught, okay? Is actually I don't know what it is, but the point is 1/this is gonna be K, So Ka, and then we'll call this R, right? We'll call this R, okay?
Yeah.
The distance here will be D, right? Plus K QB over D minus R, okay? Will that
Why
be okay?
d minus r?
Because if I'm considering this point, then it'll be from here to here.
Oh, I see. Yeah,
I
okay.
cannot say it's R already. In a two charge system, this always exists. You cannot just put R here and R here. It doesn't work. It doesn't work. Now for the V total, I'm sorry, this is square and this is square, right? Now for V total, this is QA over R plus K QB over D minus R. I think we're set up. Right? Now, for electric field strength to be 0, where the electric potential is not 0. So is it possible for this to be 0 and this not to be 0? Now, first thing first, how is it possible for this to be 0? It's a very simple thing. How is it possible for this to be 0?
When d minus when QB or QA is equal to 0.
No, then you don't have two charge. If there's a
K
two-point
equals
charge,
0.
K cannot be equal to 0. You're talking about this K. K cannot be equal to 0. It's a constant.
Denominator equals 0.
How come the denominator equals 0, then this whole thing equals to 0? What's that math? That doesn't make sense. That doesn't make sense. It doesn't make sense. You don't do that. You don't do that. The distance is not 0, right? So this cannot be 0. This cannot be 0. The charge also cannot be 0. If the charge is 0, that's not 2-point charges. That's just 1. Cannot.
Yeah.
So again, is it possible for between two charge for the total to be 0? Is it possible or not?
No.
It is.
Oh wait, if both are one is negative, one is positive, same magnitude, but different sign.
Okay, so then we have a problem there. So this is vector and this is scalar, right? This is scalar. What you said is totally correct for something scalar. If this is positive, then this is negative, then this total possible to be 0. Because this is positive and this is negative. For vector, it's the same thing as force. If you want them to be 0, the arrows must be opposite. Keeping it simple. Keeping it simple.
Yeah.
So very interestingly, instead of this is positive and this is negative, very interestingly, if you want this to be 0, this has to be either positive or negative. You think about that for a while. Either positive or negative. We have a chance for the summation to be 0. Why? Because positive, the arrow is like that and then like that, correct? And negative, the arrow will be like that, and then like that. Am I making any sense? I'm jumping a lot here. This point,
Yeah,
okay, let's concentrate on this point. At this point, if A is positive, how does my arrow look like for A?
Wait, the point is positively charged, right?
The point, no, not the point. The charge is positively charged for this guy. And then I'm talking about this point. This point will feel the electric field strength by A and of course by B. Let's focus by A first. So how does this point feels the positive charge of A? How does it feel? It feels K QA over R squared. Here's your R. And then since it's a vector, you must draw like that. That's E due to A. That's the arrow.
Wait, why does it move towards the?
Because positive charge, the arrow points into the charge, right? It's not moving again.
Yeah.
That's what it means. So it's not just here, no? It's here also. Now consider this point in relationship to B. B, let's say, is positive. I know it's negative right now, but consider it positive, then, QB over D minus R squared, right? That's the magnitude. And then the arrow direction?
The other way.
Below, if it is both positive. If it is not both positive, then you have this. And there is no way that it becomes zero. No way. No? Make sense?
Yeah.
So whether positive negative or negative positive cannot be zero, but positive positive and negative negative possible to be zero. Possible.
Oh, I see.
Okay, so we start from there. So that's for the electric field strength to be zero. All right. So our conclusion is either A and B is both positive or both negative. So far, so good, right? Right.
Yeah.
So now we talk about this. Oh, if both are positive or both are negative, here the electric potential is not zero. Does that make sense? If both positive or both negative?
Yeah.
Yeah. In fact, it is always not zero. If this is both positive and both negative, then the V total can never be zero. Oh, wow. Part A definitely possible. Definitely possible. This is very abstract. Yeah? This is not the easiest question, I suppose. So, but if you take time to answer part A.
Wait, but why is the potential not zero?
Again, because potential is scalar. You just add them up. So again, let me just give you an example. Let's say this is plus 2 and plus 4. Let's say, right? Plus 2 and plus 4. The arrow will be 0, but here there is no arrow. This is just, well, plus 2 here and plus 4 here. I mean, what is this guy plus this guy? Definitely not 0. Definitely not.
Oh, I see.
So it is possible for this to be 0, and this is not 0. Possible.
Oh.
We start from there. If you find that to be understandable, you are quite ahead. You're not thinking too abstract. Not bad.
So if the electric potential is 0 for the part B, right?
If 0,
the charges are both different. Like
must
one is
be
positive,
different.
One is negative, right?
Yes, it must be different. Then is it possible for the field strength to be not 0? Well, pretty much, because the arrow will be, actually of the same direction. So it will not be 0. It'll add up. So whatever the direction. Hey, wait. B is also correct.
Yeah, so it's both correct.
Correct. And this is something that always plays a part in the real exam question. This is not just a theoretical consideration. They kind of test this every time they give you an exam question, kind of. So it's good that you understand. It's good. It's not bad.
I have a...
Yes, Austin, you do first. Yes, Ian.
Part 3.
The ratio, is it?
Oh, no. Part 3.
Oh, I'm sorry. Right. So let's look at the picture. So S1 and S2 are switched on together. Sure. With the emitted wave in phase. Sure. In phase. That's nice. Okay, good. So detector is moved from P. Okay, no, along the line OY. So he's going here or there. I don't know where, right? And direction. Oh wait. So before we do anything, do you recognize that here there will be loud, soft, loud, soft, loud, soft, loud, soft, loud? Make sense? That's the same thing as bright, dark, bright, rough, lah.
There was no maximum.
Yeah, I know, but at this fringe, the fringe will be loud, soft, lah. Maximum, minimum, maximum. Make sense?
Okay.
Right now, stack explain the appropriate distance that must be moved before the intensity is the maximum, given that there is no maximum between O and P. If there is no maximum between O and P, then it means, of course, at O is the like the central bright load. This is like the central loud, correct? Central loud.
The maximum.
No, the zero. You call it the first. It's called the zeroth bright, or in this case, the zeroth loud. Okay. Okay. The first bright is usually this. Is considered this one. That's the first bright. This is the zero. Okay. Okay. Yeah. So if there is no maximum between O and P, then he's basically telling you O is always the zeroth loud, of course, and then P is the first loud? I don't think so, because they're not in phase. Right? It's not right. Right. So because it's also not in phase, so that means the only explanation is that the first loud is somewhere on top loop here. That's it lah. It cannot be in between P and P and O. Again, am I making any sense?
So I have to, so I have to move P up until it reaches the
first loud. Okay. So he's talking about this distance. He's talking about distance. All you have to do is find the fringe distance. This is the fringe separation, right? The fringe separation is the separation between 0 and 1, 1 and 2. If you can find this already. Make sense?
Okay.
Right. Okay. A lot of reading, but if you understand it, it's not that difficult.
Oh boy. Okay.
Austin, would you please note that note to yourself that E is a vector. Oh no, you already done that. So never mind. It's okay.
Yeah.
Yeah. That's the main thing lah. Yeah, that's the main thing. Good. I like it. Guys, I go to the bathroom for one.
Okay.
Yes, I am back. Yankin, any further question? Because we're almost out of time.
No, I just need to.
Good. I guess I don't mind your questions. Now, you say that your lecture has already finished the grading, right?
Yeah.
I mean, hasn't it advanced further that where is
It will advance further. I think we're going to quantum physics afterwards. So
so you just finished grading, like what, Thursday?
it was, it's like week one there wasn't really many because like Thursday was
So
Thursday was
physics haven't advanced much.
oh, but it will soon.
Right,
And
I
faster
understand.
than
So when is your this double slit and other tutorial? When is it the tutorial?
it will be next week.
So your tutorial is only at double slit, not yet.
Oh yeah.
Oh, so you're not really too left behind, lah.
No, but I really should be more ahead than this.
No problem, because you're using your time for chemistry and for math, right? No problem, no problem. So I thought I thought your tutorial is already beyond this, but turns out that it's not. Because then no problem, no problem. We'll catch up. Okay. Okay. So are you sure no question yet?
No, I'm pretty sure this is formula, right?
Right. Yeah. So I owe you one thing. So
yeah, which one was it? Part 5, right? Part 5 of the
yeah, correct. So I'll explain to you when I have the answer. Okay. Austin, any last question?
This one.
Let me see. Is it number 6 or?
Yeah.
Number 6. So identically charged sphere of blah 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 blah. Figure 6. Where is figure 6? Figure 6 will be. Yeah, figure 6 is going to be important. This is going to be exam. Nice. Do you understand figure 6 first? Why is it like that?
Potential between the two charges, the two spheres, right?
The V lah, basically, the V lo. Yeah. Why is it like this? Why is the shape like this? It would be nice to understand.
Resulting potential.
Don't say resulting, because V is a scalar. You don't use the word resulting or resultant in a scalar. Just say total, right? So both are positive, right? Remember? I mean, in this case, wait. In this case, when I see the graph.
No, it's just charge. They never say it.
Oh, but when I see the graph, I confidently say that both is positive, clearly.
Why?
Because the V is positive. Like I'm supposed to add them up, right? Remember, I'm supposed to add them up, right? So in the middle is positive. Near this guy is positive. Everywhere is positive. I mean, you can only get positive everywhere if it is positive plus positive. My point is, if guy is negative, for example, then near this guy, it will cross into negative, for example. It will cross into negative if one of them is negative. If that makes sense. Because closer to the negative, his effect predominates. Even though this is a positive and this negative, when you get very close, the negative will win at a very close distance.
Okay.
But since it gets more positive, then I have great confidence that both are positive. The graph is telling you this, the sentences are not. So I'm thinking that's quite important. Okay.
Yeah.
So now, if the graph is both, if the charge is both negative and negative, just want to say that the graph will definitely look like that lah. Definitely look.
Yeah.
And if the graph is positive and negative, I just want to say that the graph will definitely look like that depending on whatever the ratio of positive. Okay, can you?
Yeah.
Okay, so now let's get to the question because the graph will be useful for the question. What is the question actually?
Yeah.
Okay, determine. See the magnitude of this. You just now. He asks you for electric field strength, and is the graph electric field strength?
No. Oh, wait. No.
No. Very good. I will now quote the relationship between electric field strength and electric potential.
The differentiation of potential.
Good, which in graph is translated as gradient.
Gradient.
Here's the gradient, and the gradient will be negative. Do you understand? You're supposed to measure the gradient
Oh,
at
that's all.
1.
Oh my.
I mean, if you understand this, then you're good for exam lah. Good for you. See whether you can do the B or not. The B, wait, let me see first whether you can. Oh, you can do the B. So for the B, tell me, for the B, do you need this relationship or do you need something else?
Wait, since I have E, right? Once I have
sorry.
E.
The gradient is dV/dr. The minus is additional, right? Right? You need to minus the gradient you get from the graph. Okay, great. Okay, now yes.
Yeah. Because since both of them are identical, right?
Yeah.
So and E is equal to, like, the total is equal to Q over, like, Q1 over 4 pi, R square or R?
Square.
R
Oh,
square,
so you intend to
plus,
use this number in the formula. That's your intention.
Yeah, and then I know R, right? So for the first one be 1, and the second be 4 minus 1, so it's 3.
Correct.
Then I just divide by 2.
I agree with you. I challenge you to use the V formula instead. Is it possible? So to find the V formula is very similar, but yeah. So is it easier to use the V formula in this case or the E formula? So you have an option, is what I'm trying to say.
It's the same.
So you decide what you want to use, but for the A part, definitely you want the dV/dr.
Okay.
So now you can already appreciate why your note is giving you the summary, right? You can now appreciate that. Okay, good job. I like your progress. You're not behind, right, in the tutorial?
No.
Good. I'll see you then on Tuesday, maybe with more questions. All right, good job. Then Yankin, if nothing else, I'll see you on Tuesday with more questions, hopefully.
Right.
All right, see you. Bye, guys.
Bye.
Bye.